Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to see one more problem on basic definite integration. Let us start with problem number 5. Integral 0 to log e square of e raised to 2x dx. Now first let us consider this integral as I. Therefore I is equal to 0 to log e square of e raised to 2x dx. Here, to find the integration of e raised to 2x, we can compare this integral with integral e raised to x dx, which is a standard formula, whose integration is e raised to x. But this being a composite function, x is replaced by 2x, therefore its derivative will be divided. We have I is equal to integral of e raised to 2x is e raised to 2x divided by d by dx of 2x. Within limits, we have 0 to log of e square. Therefore, I is equal to e raised to 2x, derivative of x will be 1, therefore this will give you 2. Within limits 0 to log e square. Now let us take this constant outside. Therefore I is equal to 1 by 2 e raised to 2x 0 to log e square. Now let us substitute x as first log e square and then 0. Therefore I is equal to 1 by 2. This will give you e raised to 2 log e square minus we have e raised to 2 into 0, as the upper limit is log e square and the lower limit is 0. Therefore I is equal to 1 by 2. Here you can see we have m log a, and we know very well that m log a can be written as log a raised to m. Similarly, this can be written as e raised to log e square the whole square minus e raised to 2 into 0 will give you 0. Further, I is equal to 1 by 2. Here you can see the base is e, right? And we know that the property of x raised to log x raised to m will directly give you m. Similarly, you can see here the power will be 4. Therefore, the final answer will be 4. Minus anything raised to 0 will give you 1 only. Now, 4 minus 1 is equal to 3. Therefore, this will give you 1 by 2 into 3. Therefore, I will be equal to 1 by 2 into 3 will give you 3 upon 2. This is our final answer. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.